All right, let's talk about arc lengths and sectors of circles. And we'll begin with arc lengths. So if we have a circle of radius r, and there's a central angle theta that intercepts that circle and creates an arc of length s, then we can figure out what s is by just multiplying r times theta. Now this is really important. The central angle theta must be measured in radians. Okay? So here's what we're talking about. So I've got a central angle. That means the vertex is at the center of the circle, and that angle is called theta. And there's a certain radius r. If that theta is in radians, then this arc length that's intercepted by that angle is called s. And s equals r times theta. Pretty easy, right? The only tricky thing is theta has to be in radians. Okay, let's do a couple of examples. So here we've got a circle with a radius of 5 inches, and we're going to try and find the length of the arc intercepted by a central angle of 3 pi over 4 radians. So if we start at 0 radians, and there's pi over 2 radians, 3 pi over 4 is going to be halfway in that quadrant. Okay, so here's our angle, 3 pi over 4. And so we are interested in measuring this length right here of this circle, this arc length. And we know that our radius is 5 inches. Well, since our theta is already in radians, all we need to do is go 5 times theta, and we get 15 pi over 4. And if you want a decimal approximation, it's about 11.8. Okay, here's another example involving arc length. This time we have a circle with a radius of 20 centimeters, and now we want to find the length of the arc intercepted by a central angle of 100 degrees. So I'm going to estimate 100 degrees is about right there, a little more than 90. And you notice that now our central angle is in degrees, not radians. So when we do our calculation, we're going to have to convert to radians. So our radius is 20. So s is equal to r times theta, which is 20 times 100 degrees. And we're going to convert that degrees to radians by multiplying by pi over 180, because pi radians equals 180 degrees. And let's get our calculator up, and we just work it out. 20 times 100 times pi divided by 180. And it's about 35 centimeters. Okay, so the other part of this screencast is involving area of a sector of a circle. So let's say we have a circle given radius r. The area A of a sector of a circle with central angle theta. So let's say that we have a central angle here of theta. There's our radius r. That area right here, it's kind of like a pie slice. This area is given by the formula 1/2 the radius squared times theta. And guess what? Once again, theta is in radians. Okay, it won't work unless it's in radians. Okay, let's just do one example here. We've got a car's windshield wiper, and it rotates 125 degrees. Okay, so let's say that that's 125 degrees right there. Okay, and the length of the wiper's arm is 25 inches. So that length is 25 inches. And the rubber wiper is 14 inches. So this length right here is 14 inches. So what area of the windshield is kept clear? In other words, we're looking for this area right here. Okay, so here's the plan. Let's get the area of the whole pie slice, and we'll subtract off the area of this little pie slice right here. Okay? So if I take away 14 from 25, that'll leave me with 11 inches right here. Okay? So this is 11 inches. So the area of the entire thing is going to be 1/2 25 squared times 125, and since that's in degrees, we've got to multiply by pi over 180, and I'm going to subtract this yellow area right here. So that's going to be minus 1/2 11 squared times 125 times pi over 180. Now, if you look at this, you may notice that I can factor out a 1/2, a 125, and a pi over 180, which leaves me with 25 squared minus 11 squared. And that makes our calculation a little easier to work out. So here we go. 0.5 times 125 times pi divided by 180, and then parentheses 25 squared minus 11 squared, close parentheses, and we get that the area that the windshield wipers clear out is approximately 550 square inches. Well, I messed up, didn't I? Hang on a minute. There. 550 square inches. So that's how you might use area of a sector formula.